I'm Anil Kumar. Welcome to my series on graphing functions. We'll discuss graph of trigonometric functions in further details in part 2. Three examples to consider are y equals to minus 3 cos of pi by 2, x minus half, y equals to 2 cos 4, x plus pi minus 1, y equals to 3 sine 2x minus 60 degrees plus 1. Now, whenever you look at cosine functions, they in general could be written as f of x equals to a, let's say cos k x minus, let's say p for phase shift, plus q for vertical translation. So, for any function, the time period t is defined as 2 pi by k if you are doing in radians, or you could write t as 360 degrees by k. So that is one of the very important parameters. A, of course, is the amplitude. So A is amplitude. Q is equation of axis. So these are the general things which you need to take care of. Now when you look at the function, at times we may have something like this, which we have in part C, 3 sine 2x minus 60 degrees plus 1. Now in this case, it is very important to factor 2. So let's factor 2 here and rewrite the equation as sine 2 factored out, you get x minus 30 degrees plus 1. Now it is clear that the phase shift is 30 degrees to the right. Otherwise, you might make a mistake. Correct? So these are a few things to look at when we see the equation. So once you have the equation in the required form, as it is right there, we should work with them. Correct? So let's begin to sketch them one by one. The very first one here is y equals to minus 3 cos of pi by 2 times x minus half. So we know that the k value is pi by 2. So to find the time period t, which should be equals to 2 pi divided by pi by 2. So pi and pi cancels. You could also write this as 2 pi times 2 over pi, which is 4 units, right? So at times on the x-axis, we could have just numbers like 1, 2, 3, 4, as we have in this particular example. Correct? Now we don't have any vertical translation. Rest of the things are very simple. Phase shift P is half to right. Now some of you may like to use the coordinate points to get accuracy. So let's talk about that also. So for a cosine function, if x, y are default points, and the transfer point for this particular case will be that the x value gets multiplied by this factor. Do you see that? Pi by 2. So the x value gets multiplied by this factor. So we can write x times 2 over pi. Right? And then you have to add half plus half. As far as the y value is concerned, it gets multiplied by minus 3. So this y value becomes minus 3 of original y. So that is the kind of transformation which we are looking for. The points on cosine function, which normally when you look at, let me sketch the graph here, just a rough one. Okay, we'll do the final right there. The cos function is kind of like this, right? So these are the 5 points which you need to consider. So these 5 points include 0, 1, and then we have pi by 2, 0, So this is pi by pi to minus 1, 3 pi by 2, 0, and then we have 2 pi and 1, correct? So these are the points. Now if you do the transformation, you get your transformed points. Now in this case, we have to multiply this value by 2 over pi. So basically 0 remains at half. We add 1 at half, correct? Minus 3, so we start with a negative value. For the second case, if I multiply by pi by 2, this gets cancelled, so just half. So it is 1 plus half, which is 1.5. Let me write 1.5 here. So 0 will give us 0 only. If I do pi, then pi cancels for x. So we get 2.5. So let me write here 2.5. Minus 1 makes it positive 3. Now with minus 3 pi by 2, pi cancels. So you have to replace x with minus 3 pi by 2. Correct? So when I write minus 3 pi by 2, so this pi by 2 cancels, you get minus 3 plus half. So you get, sorry, this is not minus, positive 3 pi by 2. Okay, so 3 pi by 2 will give positive 3 plus half as 3.5. And the value will become 0. 0 remains at 0. For the last point, which is 2 pi, so it becomes pi cancels, we get the value 4, and 1 becomes minus 3. Correct. So these are your transform points. Okay, so that is one way of doing it. Now for simplicity, what I'm going to do is, I'm just going to sketch one particular wave as shown here, transformed one, of course, right? So that's our graph paper. Let's take this as our y-axis. So I'm only sketching on the right side, right? So since there is no translation, it is like perfectly symmetric to the center portion. So let's do this as the x, okay, y. Now the idea is that we have to look for 4. So if you count the divisions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sets of 4 is good enough. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that is 4 for me. So each set of 4 is like 1 for me, right? So 1, 2, 3, 4. You get an idea, right? Now we're looking into the y values going from minus 3 to plus 3, right? That's what it is. So we can have 1, 2, 3. Now in this case, minus 1, minus 2, minus 3. So this is our minus 3. And that is plus 3. This is 0 for us. Correct? So that is how you can label and then sketch. So the 5 points which we got are, so half is right there. So it begins with the bare minimum, I mean lowest point, and then 1.5 it crosses. Then at 2.5 it is at maximum value of 3. Then at 3.5 it crosses x-axis. And then at 4.5 it ends with 1 minimum. So that is your one wave. You get an idea, right? So this gets flipped over, right? So, and then translated half unit to the right. So what you get here, so you could do like this, maintaining the characteristics of your graph. Does it make sense to you? So that is how you get your transformed function. So to begin with, these are my critical points at half. This is at 1.5. Then we have at 2.5 and x-intercept at 3.5. Ending first wave at 4.5. Correct? Sometimes in the question you may have to write domain and range. domain is all real numbers. As far as the range is concerned, it is restricted. So for range, you could write as between -3 and +3, right? So I'm just squeezing it in here. You may have to find x and y intercepts also. So if required, the x intercepts, you can find y intercept by substituting x equals to 0, right? So that also you can do. So let's extend this. To find the y-intercept, x is 0. So we get -3 cos of pi by 2. So x is 0 times -12. Now that gives me -3. Now cos is even function, so it becomes pi by 4. Cos of pi by 4. So you can calculate this value from 1 over square root 2, that is, right? So which is -3 times 1 over square root 2. So this value, the y-intercept will be -3 over square root 2, correct? So if required, you can find that. We'll not do these calculations in any other video, part of this video, but we'll just sketch, okay? Let's move on and take up the next question now. Here is a very interesting question. We need to sketch graph of y equals to 2 cos 4 x plus pi minus 1. So let's find the time period t, which is 2 pi by the k value, which is 4 in this case. So we get pi by 2 as our time period. That really means what? It means that the function repeats after every pi by 2. Is it okay? So that means I could write this function y equals to 2 cos 4 x plus pi minus 1. Now it repeats after every pi by 2, so it will 2 times it will repeat after pi. So this basically is same as 2 times cos of 4x. Does it make sense to you? Correct? So shifting pi units to the left makes no difference since it is a periodic function. So I hope that is a very important realization, correct? So again, what I will do here is, we know that the function repeats after every pi by 2. So there is practically no phase shift. So we're looking for a function whose period is pi by 2, right? So I could sketch this graph as, okay, so let me draw the y-axis this time slightly inside so that I get something on the axis to write about. Now the axis is shifted 1 unit down. So what I'll do here is I'll put my y-axis right there. So this time I'll show you the sketch of the graph without points. So we'll do without points. It's much faster and easier. Now we have amplitude of 2. So let us say that this is 2 division is 1 unit, so minus 1. So we'll start with the axis which is at minus 1. So let's say this is the axis. So this is y equals to minus 1. That is our axis. Is that clear? Now we have amplitude of 2. That means we go 2 units up, so that could be our maximum, correct? And 2 units down. So the graph is within this interval shown, right? So this is minus 1 for us. Going 2 units down means minus 3. 2 units up means plus 1. Does make sense to you, right? We are only sketching one wave. Now, whenever you have sine or cosine functions, try to divide them into 4 intervals so that you get all your 5 points. correct? So the 4 intervals will go with 4 divisions. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. You get an idea. Now the time period is pi by 2. That means this point here should be pi by 2, right? Now this is half of pi by 2. I write pi by 4. This is half of pi by 4. I can write pi by 8. So this is 1 pi by 8, 2 pi by 8. This is 3 pi by 8. Do you get this idea, right? So we got our points on the x-axis. Do you see no calculations? So what we are doing is without points, no calculations. So this is extremely efficient technique. Let's move forward. So what do you do next? Well, cosine function starts with maximum, correct? There is no reflection. It starts with maximum. So that is our interval, right? So the first we get this point. Then on the axis we get second point. Then next quarter, minimum, back to the axis, and then back to the maximum. Do you see that graph? So these are the 5 critical points to sketch the cosine function. Maintain the smoothness of this function. Is it okay? So we have this function right there. So you see, this time I have done no calculations at all and sketched fairly accurate graph. That is highly recommended. So when we say sketch, it means rough sketch. Remember that. So save time. Do like this. That is my recommendation. So this is why this is x-axis. So I hope that makes sense, right? I hope it is absolutely clear. Now let's take the last one here, which I've taken in degrees. As we talked about it, we could rewrite this function as 3 sine 2 common x minus 30 degrees plus 1. Now here I will show you another very important technique. So I'll say method 3. So first one we did with points, second one we did without points, just taking 4 quarters. Now we'll do in stages in our method. So here we follow 2 steps. So we say step 1 and step 2. In step 1, we'll sketch the function without this horizontal translation, that is phase shift. So we'll sketch 3 sine 2x plus 1. And in the second step, we'll include this transformation. So we'll sketch 3 sine 2 x minus 30 degrees plus 1. You get an idea, right? So let's do this. So we'll do 2 steps method. I'll show you one particular, so we are actually moving right by 30 units. Okay, so let me this time use slightly lesser space on my left side. So that's my left side. We're moving right, so I'm just taking it slightly, and then this is 3. Okay, that's my x-axis. Now again, we divide it into 4 parts. That's kind of very critical. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. These are my 4 quarters, correct? So what I'm sketching here now is the first part. Moving 1 unit up. So each division is, this is 1, this is 2, this is 3, this is 4, kind of like this. Do you see? These are my divisions of 1. Moving 1 unit up gives me axis. So this is the axis for my sine graph. Now the maximum is 3 up. So 1, 2, 3. So our graph will go up to this point. 1, 2, 3 down. Do you see that part? So that is the range of the function, right? This is the range, which is from 4 to minus 2. Okay, Each division is 1 unit as shown here. Okay. Now the sine function begins with the axis. Okay. So this is the axis. Next quarter it goes to the maximum, comes back to the axis. Next quarter goes to the minimum and comes back to the axis. So my graph, as you can see, is defined by these 5 points. So I'm just connecting these points with a smooth curve. Okay. Not that smooth, but however, I hope you're getting it, right? So this is my first function. I mean part of it. Now what I need to do is to shift it 30 units to the right. What is my time period? Time period t in this particular case will be 360 degrees divided by the factor 2, which is 180 degrees. Do you see that? So this is 180 degrees. So this much is 90 degrees, right? So this is 45. And we'll add 45 to 90, we get 135 degrees. Since this is 90, we need 30-degree divisions. We have 1, 2, 3, 4, 5, 6, 7, only 8, kind of difficult. I should have taken a set of 3 in this particular case for 4, right? That could have been better, okay? Now, so 30 degrees could be approximated to, let's say, this much. Is it okay? 30 degrees is approximately this much. This is 30 degrees for us. So we are moving 1, 2.5. So it is almost 3, but slightly less. So 2.5. So we are moving each point that much, 2 point, most slightly more than 2. Units to the right, 1, 2. Do you see that? Now we are going to use a step number 2 and transform the final function, including phase shift of 30 degrees to the right. So that's our 30 degrees, okay? So let's sketch it. Join these points, then these 3. And there you go, right? So what we see here is that in 2 steps, we can very easily sketch our graph. So the wave which I have drawn is actually from, so one wave is from 30 degrees to 180 plus 30, which is 210 degrees. Do you see that? However, you know, this is periodic function. So it will repeat. That's perfectly fine. But I hope you understand how we could very easily get fairly accurate graph using 2 steps, right? Now, my suggestion here is that note. We could have taken 3 units. We took 4 for 45, so we could have 3 divisions for 45 degrees, okay? That would have given us better accuracy. Then 2 was 30, perfect? Anyway, so what we learned in this particular series are different ways of sketching. So here is the 2-step method, which is, I think, the best way of doing it. And then we have this using quadrants. So 4 divisions represents 4 quadrants. That helps you. And the very first one was using the points, which definitely gives you more accurate graph. It's highly time consuming. So avoid if not specified. That's my recommendation. But in any way, we were in a position to sketch all the 3 functions using 3 different techniques. So we learned 3 methods to sketch. Follow the method which suits to your situation. That's my recommendation. I hope you enjoyed this journey of learning how to sketch trigonometric functions. We'll take up now reciprocal trigonometric functions and also inverse trigonometric functions to practice some graph techniques. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.